Let us understand how the RAG system works and what is the technical architecture behind the RAG system. Okay, so if you see that the name itself, let me decode the name first, then I will talk about in detail. So what is RAG? Okay, so RAG has three words. So R stands for retrieval, retrieval. Okay, and A stands for augmentation or augmentation. Okay, and G stands for generation. So in RAG there are three steps: generation, okay, generate. Okay, so RAG has three process: R plus A plus G. Okay, so R stands for retrieval, we retrieve something, I will discuss that. And A stands for augmentation, we augment something. And G stands for generative or generate something. There are three steps. Okay, so if you really want to understand how the RAG work, so in order to understand RAG first, okay, you have to understand first LLM, how the LLM works. I mean, large language model. Like if you heard about OpenAI, like for example, ChatGPT, right? Like Cloud, right? Like Mistral, okay? Like Meta, okay? Llama, okay? These are the different LLM, okay? So if you really want to understand generative, I mean RAG, you have to understand the LLM first. What is the LLM? Okay, and how it works. Okay, and important thing, there are some limitation. There are some limitation of LLM. Okay, so this limitation of LLM give the birth or give the use case of using RAG. So why we use RAG? First of all, you have to understand why RAG. Why RAG? What is the use case of RAG? Okay, so that I will discuss in this video. That we will discuss two things in this video. That first number, why RAG? Why we need RAG? If already we have a chat GPT or already we have a LLM models, okay, then why we are studying RAG and what is the use case? And if you understand the why reason, then how it works, okay, how it works. So I will answer these three things in this video. What is RAG? Okay, why RAG? Okay, and how RAG, how it works. This let us find out these three answer of these three questions. Okay. So before I go ahead and I talk about RAG, so first of all, let me talk about the LLM, how the LLM works. If you guys, I hope you all using ChatGPT nowadays. Okay, it's become the part of our life. So I'm expecting that you know how to use ChatGPT. So how to use ChatGPT? Let's suppose this is my LLM. Let's suppose this is my LLM. Okay, and I want to use it. You can take example of ChatGPT, for example. So here as a user, we write a prompt. Okay. So nowadays, prompt is a language to interact with the LLM. So as a user, you write a prompt, whatever you want to achieve. Okay. You have to write a prompt, and this prompt goes to LLM. Okay. And LLM understand your prompt, and based on the prompt, it generates something, right? It is called generation. It generate something or it give you a response back, right? Let's suppose you want to write a poem. Okay, so you send a prompt to LLM. Okay, hey, I want to write a poem on this topic, something like that. Suppose you want to get some answer on physics topic. You send a prompt, right? I want this answer, something. I hope you know that. So you send a prompt to LLM, and LLM will understand your prompt and it generates something, right? Now here one thing I want to talk about, that how LLM is able to produce or generate something, or the output based on your prompt. Okay, this is why this LLM is so much capable to give you answer for any kind of prompt, for any topic. You can give to any topic, whether it's a science, it's a arts, it's a math, it's a computer science, it's a medical. You give almost all the topics. So this LLM is it has a brain, you can say. It's a super brain. Okay, and this is able to handle all kind of topics. Okay, so how it is possible? It is possible because this LLM, this has been trained. This is called training. Okay, this LLM has been trained on massive data, like company like OpenAI, like Meta, like Facebook, like Microsoft, like Google, they have a massive data, massive data. You can think about all the data like which is available on the open internet. For example, it can be video, YouTube video, it can be video, Wikipedia, it can be all the books in the digital format, right? All the movies, all the songs. Just amazing. It's a huge data. It has been trained on huge data. That is why it is able to answer all the different topics. You can give any topic, it can answer you. Okay. So here, what I want to build the concept that LLM has been trained on massive data and they have the context. Okay. I mean, this LLM has given so much training, they understand all the topic, almost all the topic. They have a context, they have very wider context, they can they understand all the topic because of training. Okay, that is okay. So this has been done on massive data, we know that like billions of data, that's okay. Okay, so suppose here, let's suppose I want suppose I have a question about let's suppose physics. Okay, in the physics I want to I want to understand for example, give me what are the, suppose this is my prompt, what are the uh, Newton's law of motion. Okay, it can be any topic, I'm just giving random. What is the Newton's law of motion? Suppose you're giving this prompt. Okay, so this model, this LLM know about Newton law. So because it's a part of their training. Okay, so they understand this topic and they can answer it. But let's suppose I'm giving one specific example here. Okay, let's suppose, so till here we have this concept that LLM is trained on massive data. It has a lot of they. So let's suppose it's a person, and this person knows almost all the topic. Any topic you can pick up in the world, they can give you answer. So this, so just imagine how much training this LLM has gone through. Okay. Now let's suppose I'm a person. I'm running a hotel business. This is my case. I have my hotel business. Okay, I have my hotel business, and I have some data regarding my hotels or regarding my business. It can be about my business, it can be my hotels, it can be my restaurant, it can be my guest, it can be my customer. It can have massive data, right? Regarding my hotel business, it can have massive data. So this data, which I own as a owner, this is not a public. These are the private data, right? This is a private data, this is not on the public, and I cannot this is because this is my business. I don't want to reveal all my data, all my revenue, all my customer detail, all my private data, because it's not a public, right? I'm not supposed to expose on the public. It's my private data. And let's suppose if I ask this question. Okay, uh, let's suppose my hotel name is suppose XYZ. I'm just giving some name. XYZ is my hotel name. Okay, and if I ask this question to suppose this is my LLM. Okay, and I'm expecting some answer. So I'm writing a prompt here. I'm writing a prompt. Okay, and I'm asking that, hey, tell me, tell me, uh, my hotel XYZ, why it is not growing. I'm just asking some silly question or some random question. Okay, let's suppose I have a lot of data, but I'm asking this LLM that why my hotel XYZ is not growing. What is the problem with that? Okay, and let's suppose I ask this question. Okay, this question goes to LLM. Now tell me, do you think this LLM is capable, or this LLM can give me a proper answer or accurate answer? What do you think? Just think about it. So obviously, in this case, LLM will will not give you proper answer. It will hallucinate. It is called this is called hallucination. Okay, hallucination. What is the hallucination? It means because this LLM has not seen my data. This is a very private. Okay, this data is a private data, right? It is not a public data. Okay, and this LLM, how this LLM work? Okay, LLM, as I discussed earlier, this LLM has been trained on massive data. Suppose this is my data set, okay, and all the data are internet. So LLM understand this data, okay. So LLM is very capable if we have the context. Suppose this is the context, right? So if the LLM has the right context, they can generate the right answer. But here in this case, though LLM has been already trained on massive data, whatever data are on internet, this LLM has been already trained, but this LLM has not been trained on this public data, this my hotel data or my private data, right? So here, let's suppose I whatever capability of LLM here is, I cannot leverage. Okay, I cannot leverage. In this case, I cannot leverage the power of LLM. Okay, because in this data set, which is a private data set, it will not give an accurate answer. It does not mean that LLM has no thinking. Okay, because this LLM on the massive data, they have already trained it how to interpret. This LLM has a very good power to interpret something, I mean encode something, okay, because they have already built a brain because of massive training, okay, in the pre-training model. They already have the capability or ability to interpret something, find the relationship, find the pattern in their data. They understand pretty well, okay. But here the only problem is that in this case, in the hotel business case or in my private data, LLM has no context about my data set, because they haven't seen my own data. So how they can interpret? If we haven't seen the data, then how you will interpret, and then how you will generate? In this case, what happens, they try to generate, okay, they try to make sense, okay, whatever they have learned in the during the training. And if you send this data, hotel data, which is private data, LLM will generate something at random, or maybe it is not accurate, or it can give some any answer. It is called hallucination. It is not hallucination means it is trying to pretend that I know something. Okay, let's suppose you ask something, and that person is just any person is trying to pretend that I know everything. They try to bluff. Okay, something like that. Okay, so here this LLM has already have a capability to encode something or interpret something, find the pattern. But only thing is that they are not capable. They haven't seen my data, which is private, and that is why it will not generate the right answer. So this is the problem with LLM. Okay, so let me summarize. LLM, if you ask any generic question, very generic questions, or if you ask any generic topic or generic prompt, okay, so this LLM has been already trained on the generic or open source data or open public data. So it is okay. Okay, on the general topic, any topic, you can pick any topic, they can answer you. But as soon as you send the private data, which is not available on the public private data, it will start. I mean, they have the capability, okay, they have a good capability to interpret data, find the pattern, but because of lack of context, because of lack of data, it will not generate the right response. So we are losing the power of LLM, though LLM is capable. So that is why I now you understand the concept, right? That what is the problem with LLM? The problem with LLM is that if they haven't seen the data, if they haven't have the right context, and if you ask something, there is a high chance LLM can hallucinate, or you cannot get the right context or right answer because lack of context. It does not mean that LLM is not capable. LLM is right capable. They have the capability to interpret, find the pattern, find the structure, but because they haven't seen your data, they will not work properly. That's the problem with LLM. Okay, so to overcome this, so to overcome this LLM challenge, this challenge, Meta, first time Meta or Facebook, they come up with this idea called RAG. Okay, first time they introduced RAG. That okay, no problem. I know that what I'm solving here, I know that LLM is pretty much it's a person. They understand, they interpret data, they understand pattern. But here is the problem is that this LLM, okay, this LLM has no right context. So why not here we do something, okay? If something LLM has not seen the data, suppose your private data, why not? I can build a context. I here, I will build a context here. Okay, and this context is nothing but your data or your private data or your knowledge. It is also called knowledge base. Why not? Let's do things. Let me create my own knowledge base which is not available on the public. Okay, it can be banking data, it can be insurance data, it can be financial data, it can be any private data which is not available on the internet. And LLM, initially it has not been trained. The training of LLM has not been done on this private data, but I can maintain a knowledge base here. Okay, and if I send any prompt, now let's suppose in this hotel case, okay, let's suppose I have a context, I have a knowledge base of my hotel data, okay, somewhere, okay, and now I'm asking the same question, okay, hey, tell me, this is the, I'm writing a prompt here now, key, tell me why my hotel XYZ is not growing, okay. So same question I'm asking here, but only difference is that now if I'm asking this prompt, I'm sending this prompt, now LLM has a access of my context, they have a right context, okay. So if you give the right context and you're sending a prompt, so you're sending a prompt, you're doing two things, you're sending a prompt plus you're sending a right context. Okay, if you provide these two information, a right prompt and right context to LLM, then LLM will understand your prompt from the context, it will do understand the pattern, and it will generate the right answer. Okay, so here whatever problem had we had with the LLM, that LLM was not capable, right, without the right context, it was hallucinating because it has no proper data set or proper knowledge base, and we are not sending our private data, so it was not able to generate the right answer. But we can overcome that problem by adding one context or knowledge base, and we are adding a prompt and knowledge base, then it will start sending the right answer. This is the whole, this is all about the RAG. Okay, so this will solve the problem. Okay, so this is on the basis of this, if you understand this concept, so this is how the RAG work. Okay, this is how the RAG work. Okay, so now you understand what is the RAG, right? You understand the use case, right? First of all, this is very important. I hope you got the clarity. What is the use case of RAG? Okay, and if somebody asks you, if already we have a LLM, then why we need RAG? Why RAG is needed? Why we have the requirement for RAG? So this is the problem. Okay, so LLM will hallucinate on the private data, and you will not get answer. So for that, we have to add a knowledge base and prompt. Okay, so this is the use case. This is a very high level use case. Now, how it works? Let us understand it. Okay, so now I'm going in the technical, little bit technical how it works. Okay, so let me explain that. So as you know that any RAG application, if you're building any RAG application, suppose this is my LLM, okay? So this is very important. Any RAG application has a context, or it is also called vector database. We have to store our context somewhere, okay? Suppose hotel document, like what is my, for example, it can be like what is, it can be my revenue for last 5 years, it can be my customer, it can be my service, what service I offer. Okay, it can be a lot of pattern, I can store a lot of data so that I can build my own knowledge base. Okay, so there could be here, there will be one database, there will be one database. Okay, and generally it is called vector database, vector DB. Okay, so we convert our document into vectors. Okay, so this vector database is a storage, it becomes like a knowledge base. It is my knowledge base. Okay, so there are two entity here involved. If you're building a RAG application, you need a LLM, it can be anything, and you need to maintain your knowledge base, whatever document you want to save into vector form. That's why we use a vector database. Okay, so these are the prerequisite. Okay, now how it works. So suppose now you're sending a prompt. I'm assuming that you are already have a database, you already maintaining a knowledge base, and you're consuming some LLM. Now you send a prompt. Same question. That tell me my why my hotel XYZ is not growing. That is my same prompt. Okay. So how it works technically, so suppose I'm sending a query, my prompt, right? And you know the prompt, right? The prompt has what? Why my hotel XYZ is not growing. This is my prompt, right? So for this prompt, what it is called query, okay? For this query, what happens? There are some prerequisite, okay? That is why, as I discussed, like RAG. So RAG, the first term or first letter of RAG is called R, which is nothing but retrieval. Okay, let me, so first what happened, first retrieval happened. So what is retrieval? For this query, whatever query you have, whatever prompt you have, the system will first try to find the, because see, in this my knowledge base I have multiple documents. Okay, I can have multiple pages, multiple documents, I have multiple vectors, by the way. Okay, so I can have multiple documents. I can have D1 document, I have a D2 document. Let's suppose I have a page. Let's suppose, I'm just example, suppose this is my page of about my, suppose this is my 10 years of revenue history. Okay, I'm running a hotel business and I have this document, suppose it's a PDF format. It's a PDF format, and I have a 10 years of my history of my revenue. Okay, and I'm inserting this document into my vector database in terms of vector. How to do that I will talk about later, but let's assume right now that we are ingesting this data into my vector database. And when we ingest this PDF file will convert it into multiple documents. We call it D1 document. I'm giving some name. It can be D1 document, D2 document, D3 document. So it is called chunking. Okay, so we chunk or we split the whole document into multiple small pieces, and this whole, each piece is called document. So it can be D1, D2, D3, D4. So let's suppose this PDF is present in vector database in terms of document D1, D2, D2, D3, D4. Okay, and I have a query. Let's suppose this is my query. So the first part, what will happen, that what the system will do for this query. Okay, whatever text I'm writing in my query, for example, XYZ hotel revenue is not growing. This is my token, right? In my query, this is my token, small token. So what the system will do, it will try to find the similar documents. Suppose I have three tokens or four tokens in my token, in my prompt. Okay, so for each token, okay, it will try to find the similar document. It is called similarity search. Okay, so let's suppose it found that based on the token, document number D1 and suppose D3. Okay, they are very similar, very close to my token. And how it happens, it's a technology, it's called embedding. That's will be covered later. Okay, but right now just start to build the intuition how the process happens. Okay, so for this token, suppose I'm writing a prompt and my prompt has suppose 20 tokens, 30 tokens. Okay, and for each token I need to find a similar document which are sitting in my knowledge base. And suppose after the process I found that my D1 document and D3 document are similar for given token. So it is called retrieval. So this process, okay, this process to find similar document, to find similar document for given token, or you can say prompt. Okay, so this process is called what? Retrieval. So we, in the retrieval process, the first process, we find the right retrieval, we find the right document for given prompt. Let's suppose I found D1 and plus D3. So this is my right document. Okay, so I got the right document which are sitting in the vector database. And how it happens, what is the technology behind it, will cover later. Okay, it's called similarity search. Okay, so this is the phase number one, or the first step. I find the, for a given prompt. So till here, for given prompt Q1, I find my right document. Suppose D1 plus D3 is the first part. Okay. Now second part in the RAG is what? First is a R, which cover right now. It is a retrieval. We are retrieving the right document from a given token, a given prompt. Second word is, second text is A, R A. Okay, R A G. So the second is the A. Okay. So A stands for augmentation. Augmentation. What is augmentation? Okay, so here, if you remember, let me go back. In, suppose you are writing a prompt here, you're writing a prompt. okay, and you're calling LLM. Simple. It's a vanilla LLM. Okay, we don't have any knowledge there. Okay, simple. So here we are sending a prompt die prompt to LLM. Okay, but in the RAG, what happens? Suppose this is a vanilla. This is a simple LLM call. Okay, simple LLM call. But in case of RAG, what happens? So we send a prompt. Okay, we send a prompt, and in the retrieval process, in the first process, already I have find two documents, D1 and D3. Okay, so we do augmentation. So what is the augmentation? Combining or merging or adding. Okay, so we add prompt and my document D1 or D3, suppose, and I'm calling it as a context. Okay, I'm giving its name as a context. Okay, because d1 and d3 has the right context for given for my given prompt. Okay, so here what I'm doing, I'm adding two things. In the previous step I got my context and my I have already a prompt. Okay, so I'm combining prompt plus my context. So this process is called augmentation. It is called augmentation. So I'm augmenting my prompt with the right context. Okay, and this right context I have already found in the first step. This process is called augmentation. So here in the RAG, what happens? Now let me compare. Okay, so here in the simple case, we send a prompt to LLM. This is a simple case, right? Where I'm not managing my own context base. This is a simple, but in the RAG, what happens? In the RAG application, what happens? We are not sending only prompt. This is my LLM. Again, we are here again using LLM, okay? But here, in this case, we are not only sending prompt, we are sending prompt plus context. We are sending these two things. Okay, and these two things, this when we combine these two things, we call augmentation. So we are sending prompt plus context to LLM now. So this is the difference between simple LLM call, this is vanilla LLM call, and this is a RAG call. So in case of RAG call, when you're interacting with LLM, you are sending augmented prompt. You're not sending simple prompt. Okay, in case of simple case, I'm sending simple prompt. I don't have to maintain a context here because I'm using generic topic. But in case of a specific use case, you have to use prompt and you have to use send context. Then LLM. Now LLM has the right context. Okay, because you already got the right context from the previous step. So you got the right context. Now LLM has the capability to understand the pattern, because this is what LLM has been trained. They understand the pattern, the structure of your context. Okay, and based on those learning, because LLM has been already trained, they already have built the learning, right? How to interpret, how to understand the structure. So whatever context you provide and whatever prompt you have, based on the prompt and based on the context, now it will give you a right answer. It will not hallucinate right now. Okay, so it will give you right answer. Okay, so now this process is called generation. So based on the augmentation, this process is called augmentation. Okay, where you are augmenting the prompt with the context. This is called augmentation. And once you pass the right context, now LLM is generating something, because this is the job of LLM to generate something. So this is called generation. This is called generation. Okay, so there are three steps now. So I hope now you're able to understand how the RAG work. So RAG has three important steps. One, our step number one is called retrieval. Retrieval. Okay, retrieval means finding the right documents. Finding the right documents from knowledge base. It can be vector database. This is the first step. Second step is augmentation. Okay, so here it will add your prompt plus your context, your retrieval, which you got it. Okay, it got added. It is called augmentation process. And last, it's called generation. So we are sending prompt along with the context to my LLM, because in the center we are communicating with LLM. So lastly, LLM will generate something. There will be some generation, and these generation are very accurate. Maybe it is not hallucination. Okay, so this is how the RAG work. So if I draw something. Let me draw again. Let me draw something now. Let me draw the diagram. So this is my LLM now. Okay, and let's suppose this is my vector database. I'm just writing component. This is my, suppose, the knowledge base. This is my KB, or you can say it's my vector DB. Okay, it has all the documents. So I'm writing a prompt here. Okay, so it does, step number one, it will go to knowledge base if you're sending any query. Okay, and it will give you back document, suppose D1 and D3. It is called context. Okay, and then it will combine your prompt plus context. Okay, and it will send to LLM. Okay, and LLM will generate you response. This is what happens. It's pretty simple. Okay, it's very pretty simple architecture, and it will generate your answer. Okay, and what is the use case? Why we use that? To avoid the hallucination. Okay, because LLM, the use case is that to avoid the hallucination. We are avoiding hallucination. Okay, and we are training. This is also that we are training our LLM on my own private data. This is very important. Okay, because LLM has not seen my private data. So with the help of this concept, okay, let's suppose you are a bank, and the banking is very secure, right? You cannot publish all the data on internet. You have very huge amount of data, which is a private data, and you want to apply some, you want to build some generative application, generative AI application, kind of track. Okay, suppose you have an insurance company, you have a healthcare company, right? Anything, any organization, any company which don't want to expose their data on internet, but still they want to leverage LLM capability. The RAG is a right situation. RAG is a right application. You can build a RAG application and you can solve a lot of business problems. Okay. And here one thing, that data is dynamic. This is the one great advantage of RAG is that, let's suppose today you added some data in knowledge base. Suppose you are maintaining a knowledge base in vector DB, right? Suppose right now you have some data. Maybe after 1 year, 2 year down the line, your data got updated. So here I have a freedom, I have a privilege to update my knowledge base, which is not possible in the LLM. Okay, when the LLM is trained, they have a cutoff date. Let's suppose assume that today Meta is announcing that I'm releasing one LLM. Okay, so whatever data is available till today. Okay, so those has been the part of the training of LLM. Suppose we have a cutoff date. Okay, but let's suppose after today there could be multiple data on internet, right? So this data has not seen by LLM. There's some cutoff date. Okay, but in case of RAG it is not the case. Okay, because I'm maintaining my own knowledge base, right? So I can keep adding here, I can keep deleting, I can updating, adding anything. Okay, so there's no limitation of cutoff. So still I'm leveraging the LLM capability which has been already trained, and still I have my own knowledge base, and I'm leveraging LLM using RAG application. Okay, so this is how the RAG work. Okay, I hope you got the whole understanding, and this is the architecture. Okay, this is the process. Okay, this is how they work. Okay, now after this, there are two important process, or you can say there are two important components of RAG. Okay, if you're able to understand. Okay, the first component is called data ingestion. Data ingestion, because as you know that we have to manage our own knowledge base, right? We have to manage our vector database, right? We have a vector DB where we store our private data, which is not on public, and this is under organization. You can control it completely. This is your call where you want to put. You want to put on the cloud. It can be on the cloud. It can be on premise. That depends. This completely is under your control. Okay, data privacy, everything is there. So the first part is the data ingestion. Okay, because without data you cannot perform RAG. This is the prerequisite. Okay, second part is retrieval. Okay, retrieval. Okay, So retrieval sense, I mean how to perform search. There are multiple technique how to perform search. Okay, there are multiple technique. Okay, because in this video I'm just covering the very high level architecture, but under the hood, okay, in the retrieval process, when suppose you want to retrieve something, there are a lot of architecture, there are a lot of process, there are a lot of techniques, retrieval techniques, okay, that you have to understand. There are multiple options. Okay, so in nutshell, in summary, there are two important components in RAG. One is called data ingestion. So how to, there are multiple way to ingest data. Okay, and this is the first part. Second part, how to retrieve the data. Okay, so in the next video I will talk about I hope in this video I was able to establish the basic concept what is a RAG system, and in the RAG in the next video I will talk about data ingestion, the architecture of, okay, architecture of data ingestion in RAG. That I will talk about data ingestion in RAG. There are multiple. There could be multiple way you can ingest data. Okay, and this can be, this should be very robust. This could be this could be scalable, and it can be distributed. There are multiple architecture behind it. I will discuss in the next video, because this is the backbone. I would say this is the backbone of your RAG system. Okay, this is the backbone of your RAG system, data ingestion. Okay, so I will cover in the next video. There are multiple architecture, multiple technique how to ingest the data, so that it can be scalable, it can be low latency, it can be a highly distributed system. I will discuss in the next video. Okay, so this is all in this video. I hope you got the clarity that how the RAG work, the basic concepts, the architecture, and what is the use case. Okay, this is very important. What is the use case of RAG? In what case we build a RAG application? Okay, and what are the challenges with LLM? Okay, and actually RAG is trying to solve some problem over the limitation of LLM. If you understand the what is the limitation of LLM, that's what RAG is trying to solve it. Okay, that's all in this video. I will come back in the next video, and next video I will talk about the architecture of the data ingestion pipeline, how to ingest data in RAG system. Okay, this is all in this video. Keep learning. I will come back in the next video. Till then, goodbye. Take care. Keep learning.